as he mentioned, I work with IBM, I work with the Eclipse team, and before we get into how the source code gets transformed to the bytecode, I'll just want you to get a context of why I'm here and what product what we use and how is Eclipse related to all these stuff. So let me start with, how many of you use dark mode? How many of you use Eclipse? Okay, so whether you use Eclipse or VS Code, how many of you use VS Code? Intel, yeah, I know, that's our competitor. Right. So use VS, at least I'm happy that somebody uses VS Code because they internally connect to us, to Eclipse JDT. So when you open any IDE, maybe for example, for me, I know only Eclipse. So when you open an Eclipse IDE, this is something what you see, right? You have a perspective, you have source code, multiple stuff. Now, with a famous plugin architecture, this is provided by a lot of plugins, like that connects to Eclipse. You have the plugin development environment, you have the JDT, you have lots of other plugins. But JDT is Java development tools, and the Java part of it is provided by JDT. So what does it really provide? You must have used, whatever IDE you have been using, you must have used some of these debuggers or formatter, code refactoring, a lot of people must have used, right? Completion, etc. So how do they provide? How do we provide this? We provide, these features are provided by some of the internal pillars. That's what we call. This is called, like, there is a Java model, there is a abstract syntax tree, and there is a search. These are the three pillars. So for example, when you do a method refactoring, the search comes into play, the AST comes into play, the search for figuring out where exactly, you're changing something, you're changing a variable, so you have to figure out where all the variables have to be changed. Some of these things. But can you see the bottommost layer? That bottommost layer is something that is not really visible to a lot of people, and we'll come to what exactly this bottommost layer is. And that is something that actually transforms the source code to bytecode. And this is of course, as all of us know, it is the compiler. This is the, now when I say it's a compiler, a lot of times in the conferences they ask, okay, so you use Java-C underneath Eclipse? No, we don't use Java-C underneath Eclipse. We use our own compiler. It's called Eclipse Compiler for Java, or I can kind of say that there are two compilers in the world. One is the Java-C provided by Oracle, and one is the compiler which we provide. So we are going to go deeper into the compiler and see how the source code to bytecode transformation happens. How many of you work with bytecode? Okay, I know, Samir, you're an exception. So he was heading our group earlier in IBM. He has moved out. And when I talk about compiler, it is essentially, we take the source code. What is source code? It's essentially a text, right? It doesn't have any structure. The first thing the compiler would do is to get a structure out of it. And that structure is represented in a tree called abstract syntax tree, or AST. That's the intermediate format. Now, once you have the intermediate format, then the backend kicks in. And then it does a lot of stuff and generates the code. So how many of you have booked an apartment in Bangalore? Very less, very nice. How many of you have booked an apartment when it is in the construction stages? Cool. So when you really look at it, by the time the structure is up, your 70% of the money is gone, right? And then they say that the rest of it you pay slowly. Similarly, we fix the structure first. We look at the blueprint. We look at the so when you construct something, you get bricks, you get iron, you get cement, and then you have a blueprint, some specification. And then there is this guy, the mason, the front end person. He comes and builds the structure. Of course, there's a villa, but if you have a flat, you just build one over the top of the other. So consider each floor of an apartment as one method, and method after method, and the entire building is a class. So you just build up the entire structure first. That's how the compiler works. And then the backend comes, and we build the final product. But if you really look at it, there are a lot of other things also that come in. You have to fix the doors, you have to fix the pipes, you have to fix the lamps, sofa, etc. So consider these as something like the variables, the statements, etc. inside a method. That comes inside the method, it comes inside the apartment. So that's how we should relate. So initial, when you look at the structure, you don't consider any of those things. The front end just ignores them and gets the structure up, the abstract syntax tree up. Now let's forget everything for the moment. Let's forget about the apartment. Let's forget about the Java file, and let's look at a nice place, a scenery where my intention, okay, not to relax, maybe to relax, but the scenery is there, the picture is there, and I want to represent the picture in a tree format, in an intermediate format. How do I do that? In the last conference, somebody really asked me this, actually, but this is not what we are not going to look at AI. It's more about figuring out the similarity, the analogy, and it's a way to explain it easier, how the text file is converted into the syntax tree. So what does the compiler do? It accepts a picture, or it rejects a picture with some helpful error message. So when we say we need to get a picture, the picture up, analyze such a complex picture, it's as if we are saying, 22nd August 2023, we say that we have to put a rover on the moon. But we know that it's not possible, because it's the next day, the rover has to be the moon. So it was a long journey. So let me just take you through how the grammar evolves, how the specification evolves in the language. It takes some baby steps. Some are successful, some are not so successful. So when I say successful, not so successful, how many of you heard preview features which the Java has come up with? So preview features are something which they try out, and sometimes it's not successful, they just withdraw. So there are things which they do. So let's just start with a very simple picture. And you have to describe the picture, right? Finally, it's the computer it's the program that makes that picture, analyze that picture. So we say, a picture specification says it has two components, sky and water. Order should be from top to bottom. All components are mandatory. Believe me, it is version 0.1. So if this is the version, then do you think this picture gets accepted? First picture, does it get accepted? Let's say the color is uniform. Why? No, the specification. What does the specification say? Component? Yeah, let's say the color is we assume it is uniform. I couldn't get a picture which was very clear. So this way, and you can see that order is from top to bottom, and the components are mandatory, all the components are there. Then let's say, is this accepted? It is not accepted, right? Because some of the components are the first picture does not have one of the components, and second picture there is a boat associated, which makes it non-uniform. So this boat is something, it's like an aberration. If you look at a small thing, that's like missing a semicolon. It's a small error. And this is like missing some big type or something like that. So what does the compiler do? Compiler can either flag an error. I mean, it has to flag an error, of course, that's mandatory. And it also tries to go beyond, recover the error and say that I can assume that the next that this is an error, I'll probably ignore this, or I will, that is, ignore this picture, this part of the picture, or replace this part of the picture with something else, look at somewhere and replace it with something else, and then continue so that the compilation does not stop. And this is how actually we do the recovery in the compiler. Version 2.0, we add more objects so that it is it gets the picture gets more and more complex, and we can see that the color can be anything, that can have objects, and then the both picture gets accepted, and so on and so forth. And then wanted to show you this primarily because this is a picture on the beach, and the first picture gets accepted. Second picture does not get accepted because it says the type of the object must be one of sand, plant, rocks, or a compile time error of this. Now, why is it so important? Look at language specification. The specification is written like in this way. It says like the type of the expression must be char, byte. Any guesses what are we talking about in the specification? Variables can be any class, right? Sorry? Declaration. What is the type? There is no, we specifically mentioned the type. So it is, let me give a clue. It is somewhere, it's a use of a variable in a particular control flow structure. Right, thanks. Switch before 21, before Java 21. On 21, the entire thing changes. We allow pattern switches. We'll come to that. So at some point we have 4.0. We allow everything in the any kind of picture out there, and at 10.0, that is at some 10.0, we have a full-blown specification that accepts this picture. So when we'll see what it means by accept this picture. Now it's all fine. You give something very similar to it, it will not compile. It's like you give the C and Java are very similar, but at some point there are differences. Now, so we talked about the text so far, but that's all English. Now, how do we translate that into something which is more formal, which we can program? And that's how we have the grammar part, which we say picture contains of components. That is, how many of you have done automata theory? And yeah, so probably, okay, cool. So at least a lot of people have done. So it's like the production, right? So the picture contains of components. Components will have sky, water, land, sky or water or land or something like that. And components there can be one component after another. It's like the class, we can have fields, we can have methods. And there could be a number of fields and number of classes. So it's exactly similar to that. And also, we accept this and then we do something else also. We create, we accept that, okay, we find that this is a component, this is a method. Then we create some nodes for the abstract syntax tree. And that's how the intermediate representation comes up. Yeah, so it's like this. You have a blueprint, you have a scenery, and there is a front end, and it creates an abstract syntax tree, which like it's just a tree structure, which says, okay, it is a scenery, it has a sky, it has a water, and it has some properties to it. Like the sky is blue, it's plain and it's blue, and it contains clouds, sun, etc., etc. So now we have a structure on which the backend can work. Now that said, this is our front end, and the front end, what does it translate to? It translates the source code coming to Java. It translates the source code, looking at a specification, the blueprint, into an abstract syntax tree, which is visible. Now this is something which you can look at it. You can look at, any of you have installed the element view. You can look at maybe if there is a time after the presentation, we can take through this. You can install the element view and look at all these different possibilities, different structure of it. It'll be bare bones. It doesn't contain anything. It just says that it's a class, it's a method, etc. Now we talked about. So this is essentially it's a front end that contains a scanner and a parser. Scanner is like picks up all your keywords, all your say class, name, etc. And then the parser comes in, which is another part of software that gives meaning to it. That meaning comes from when you identify that it's a class. So we say it's a class, something like that. Hold on to it. We'll come to that. Now this looks like something which we can. Everyone is talking about machines and automating and stuff. So can we automate this? Because we have a blueprint. Can we have a 3D printer for this? Like you have the specification, the blueprint, and if we are able to create a generator, can we do that? Apparently we can. So what we do is we feed the grammar, the language specification, that is and translate into the grammar. So this is an if expression grammar, which says an if statement contains an if statement is defined as an if statement, then there is an expression, and then there are statements, and so on and so forth. So then you have something called a JIXPG parser generator. Sorry, it will generate a software for you, a parser for you, which will accept that source code of which adheres to this particular blueprint, this grammar. It also adds these consume methods for you to create the nodes of the abstract syntax tree, and then gives you the front end. So what you have is the machine, the front end, this part. This part is the machine, what we have. Now what do you do with that machine? So we have the machine. Then why are you guys paying us? Before you say it's a CSR initiative, let me take you through some of the stuff the compiler does. Any issues over here? All of you Java, anyone, all are Java programmers, right? Or at least have worked with Java sometime. Yeah, some of these are very. Any issues here? Huh? It's a reserved keyword, so you cannot. So very simple. So that's an error. So the compiler has to figure out an error. So it flag an error. Any issue here? What is what? Reserved keyword? You can use it as a variable. So what is the difference between int and var? Yeah, that's correct. Yeah. So one difference is when you see an int, you know it is an int. It is a reserved keyword. You just cannot use it, right? So compiler writing was much easier. It was context free, from the theoretical perspective. And so wherever you find class, wherever you find if, wherever you find int, it's an int, nothing else. But wherever you find var, you have to look around. It's not context free. You have to look at the contexts, the context around it. So that's the compiler's job. And then it will tell you whether it's a. By the way, can we have var semicolon? Correct. Yeah. Yeah. So can you ask me? Can I ask you what is this var? The second var, this fellow. This I know. What is the type of that? How do you know? How do you get it? Correct. After looking at the context, after looking at what is on the right side. Now, if I have var semicolon, what is the type of it? Unknown. Correct. So you should not be allowing it, right? So these are the things which the compiler is supposed to give. Now, anybody familiar with this? Is this a similar one? Is this correct? Or if it is not correct, any? Wrong answers are also fine. So, Second one is? First one is? Both are correct. Actually, depending on the context, as long as you put it on, if yield is a variable, then both are correct. In the default case, in this particular thing, the first yield is of course a reserved keyword, and second yield is a identifier. I'm not planning to stop. Okay. Can you? Is this? Yes, no, maybe. It depends. The diplomatic answer. Anyone use this when? Oh, it's a new one. It's happened. It's come in 21. It was there in as a preview feature earlier. So have you used the switch patterns? So if you use switch patterns, we'll just come to you since you. So it's like this. We saw that switch cannot have anything other than so many types, but in this 21 onwards, switch can have types, and it can also have conditional. Earlier it was called guarded patterns, where you are switching on a type. So in this case, you're not switching on a value; you're switching on a type. The type is a number here, and then we see that if it is what are the different types a number can have? What are the subtypes of number? Right, integer, long, double, float, etc., etc., etc. Right. So when you pass a number, then if the case is like integer, then the compiler says, okay, flag, this is not a normal switch. It's not a value switch. It's a type switch. So it's integer. If the case is if it is an integer, and when equal to, so when here is the first identifier, and when so on and so forth. So it is if it is equal to 100, then return 100, or default is 0. You can have switch of integer, switch of float, etc., etc., etc. So yeah, so then we also thought that it's about it's not just the compiler, right? The compiler is the bottommost layer. Then we are building a lot of stuff, the IDE stuff, all that. Now the completion is another pain. I mean, another problem here, where you are dealing with incorrect programs. Like think of that error recovery part, right? You're of the scenario. So when you type control space, then you come up with the IDE has to come up with a list of possibilities, and these possibilities have to be semantically correct. You just cannot put anything. So that's another part that the compiler does, or the compiler gives APIs for the upper part to do the similar in default, etc. Nothing. Now search refactorings, we just talked about it. This is about, we are changing, so we want to change the name of something. Then let's say first dot resolution, and then we figure out where all the searches are. So again, the compiler will have to do some groundwork. Again, the compiler does not do that. Compiler is pure compiler, but it provides APIs where through the different stages of the compiler, what we actually do is we take these types. Whenever we find the types, suddenly we just put it in it's not a database, but it's like kind of a database where you store the indices, and then later point we pick it up and then check for the type resolution, etc., etc. So wanted to tell you this is how the additional work this part of the compiler would do. And yeah. A good question. So why? I think this question should have been asked even in Java 10, where the var was introduced. So at that point, the point was like Java keywords were increasing and increasing, and they said this cannot go on. At some point, we are going to have a lot of constructs. So Java is moving into pattern matching kind of stuff. So there you require a lot of variables, and they didn't want to keep everything. Now that is one. Now there are existing programs, source code which have for example, var. So when var was introduced, there were people cribbing that, I have a type called var, but would you put a type called var? because you don't because it starts with small letter where. So when you put a type, conventionally it has to be a V capital. Yeah, but there are some characters out there who writes all this. Then you have keywords like when, you have keywords that yield. All of these things had problems. So they said, we'll do it. It's very easy for the programmer, but tough for the compiler, because then we had to go back and forth at some point in time. Yes. So ideally, as a programmer, you should not be declaring, unless you're migrating from an existing code. You already have an identifier called yield, right? So identifier can be yield. So if we say that yield has to be a reserved keyword, then the old programs which had identifier yield would not have worked. So otherwise, if you're writing a new program, it should not be. You're right. Thread yield or this yield. Like, so earlier it was break. Now the break was so there was a preview feature where they tried, okay, let's not do yield, yield never came up. It said, let's do break. Break is an existing keyword. To implement that, it took us a lot of effort, because break does not have a value originally, right? Now you have to add the value to break. So the break is a go-to, then it has to have a value. So it was like, well, then they started with this yield. And then the good thing is they stuck to that, stuck to the idea of this how we'll do. Huh. No, none of these things are recommended. What I am saying it is, no, it's 2 when is also not recommended, 2 yields are not recommended. So unless you want to keep your job or something. And now, you guys still are not convinced that why they're paying. So this comes with every 6 months, new features come. So every time, so you have some of these where switch expression, earlier switch statement, there was no way the switch could return a value. Now we have switch expressions, right? But the switch can return a value. Text block, records. Records is a very good. If you have not used records, I really recommend that you should use records. How many of you know what a record is? Okay, record is a constant class for all of you. So we'll just touch upon it. Then unnamed is not actually upcoming. It's already come. And then we have value types that will probably come at some other point in time. So these are the, just wanted to show off that a lot of things are coming in.
A lot of programming includes music, features, helvetic content, causing unnecessary growth, and making it more difficult. For example, they added some primary constructor thing to C#, for example.
Okay.
Which is weird. I mean, there's a lot of things behind the scenes that sometimes if a newbie person might not.
Yeah. So good question. I don't know. So with Java, what's happening is, at least Java used to have 2 years, 3 years release. Now at least they have 6 months release. Doesn't mean that they pump out features every 6 months. They pump out preview features, and preview features was like out there for 2, 3, 4 iterations. Sometimes they drop. Sometimes when people are fine with it, then they make it standard. So I feel is a good way that forward that it is being considered that way, rather than saying that this is a feature, you use it. You say this is a feature, you try it out, get us feedback, and do it. Yeah. It's not slowing it down. It is actually giving the users different. No, it might be slowing it down in some cases, but there's one case which I can show. But it gives you the different programming paradigm. For example, if you're looking at patterns, that is a new programming paradigm. That will give you the different way to write programs. And value types, when it comes, that will probably speed up. You don't require so much of memory. You can. So there is no single answer to that. Depends on the feature. You're welcome to join the team. Yes, sure.
So more of the difference between some of the new languages in Java has always been that Java was always developed as a business application. So the focus was on trying to encompass the needs of as many types of workload applications as you can the cloud thing, additions were made or adjustments were made when Java was better in the cloud. Now when these newer language stuff coming up with newer language features, they are either add the community or the GCP takes a look at what will benefit in certain kinds of workload from the new language features, and those are the
Thanks, Amir. So I generate the bytecode, and that person, that guy, runs it. So he is in the runtime part of it, you know. So he has better view of the how the performance does. For me, it is just generation. So for us, performance is we cannot publicly say not so important as him. So yeah, will not pay you. Of course, it's a open source thing. So if anyone is interested, please join. The mountain behind is where we go the day after we release. So that's also coming back to the dairy feature. So we have the front end. You created the abstract syntax tree, and that was just the front end, right? Now we have some intermediate structure, and that is the one which is middle. Then there is a backend, and then we generate the bytecode. We not only generate the bytecode, we can actually transform it to something else. We can that's how the method refactorings. So we look at the abstract syntax tree, and then you can change the method to something else. So just for the notes, this picture is of the same place, taken 13 years separate. So, yeah, the Christmas tree doesn't really work here. The example where the backend is like you have the abstract syntax tree, which is like the Christmas tree, and then you have kids coming and putting a lot of stuff one by one. But we are in Bangalore. We are about building, booking apartments. So it's like the plumber comes in, the electrician comes in, the carpenter comes in, and the painter comes in, and all of these people have to do different jobs. And sometimes they are like you cannot paint before the carpenter comes in. You know what will happen. So there is this the sequence of things very similar to compiler pipeline, where we have the type resolution, the type inference, the flow analysis, and finally the code generation. Now, code generation is like something which uses a lot of stuff with the earlier pipelines use. And at the end result is the bytecode. Let's look at one of these, all of these rather. So type resolution, what exactly is a type resolution? So the compiler comes in and it says, my class, my class is a text, right? How does it, so it figures out what the type is. And why is it important? How is it not straightforward? It actually looks at what are the types that are available to you. Have you used list in the code? List you used, right? So when you type list, what comes for completion? Type. No, so which is the type that comes? Java util list or Java AWT list. Yeah, and I don't know why. So there are two lists available. So then you have to look at when you have list in your program. The compiler will have to look and figure out which list is in your scope. How is it? Because it looks at the import statement and then figures out, okay, you have to import that particular list. So that's how this list type is resolved into that particular definition. It just finds out what is the definition. That's why the type resolution is there. And it also, yeah, I think I'll just leave it at this. Type inference. Type inference is, we provided type earlier. Here, one place we are not providing a type. What place is that? The diamond operator. Yeah. So the type inference, the compiler has to figure out what exactly is the type. Because there is no type there. Where is it? Yeah, in the new array list, right? They are a little more complicated, more and more complicated as you think about lambda, and becomes even more complicated when you think of records, which can take generic types. So, okay, so I'll stop the type inference part and move on to flow analysis. Don't laugh. The code is only for example. Any problem with this code? I know it's a stupid code, but otherwise, any errors? Okay. Can't. So every time I show the code, may not be there is an error. So there is no error here. So, but is there an error here? Actually, there is an error here. You can see where the error is. It's not initialized. It's not initialized, right? So how does it show? So it show because of due to a part of the compiler which is called the flow analysis. How the control flows. No? And why do we have to show it? It is actually a part of the language specification, chapter 16. If you go, it has the concept of definite assignment, etc., 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 and which says you have to show an error if there is a. So it's part of the standard. Of course, to make the compiler better, you can do much better things. We have the null analysis. I'm not sure how many of you use the null analysis that is part of the Eclipse compiler. If they come, that's completely based on flow analysis of the compiler, built into it, and done by somebody, an expert called Stefan Hermann. So if you use Eclipse, you can try that. So we said that it's going to be like this. There is an AST and it converts into a bytecode. But actually, let me take it one more level and say that there is type inference, type resolution, flow analysis. All of these things will decorate the abstract syntax tree with a lot of information. The type information, the method, the parameters, etc. And then the code generation comes in and generates the code, generates the bytecode. So let's get into this beast of code generation. So I know it is all, many of you know this, but when this JVM generates, the Java compiler generates bytecode, and the JVM runs it. The instruction is like it's not like you must be familiar with this x86 64 and other places where you take operates from registers, etc. But that's not like the case. It's a stack machine. So every instruction expects the operands, if there are any, to be on the stack, and it takes the instructions. So for example, if you're looking at adding two instructions, integers, there is a instruction called iadd. So what does it do? It expects that the two operands are there on the stack, and then it does what it does and puts the output onto the stack. So the stack gets reduced by 2, which is like what you see here, operand stack, that's input, and then the result is put onto the stack. So that's how this machine works. And if you look at the code, it is very simple, right? There is a sum, and how does the code look? If you don't understand the bytecode, it's fine. It is very simple. It's I load 0, and that is the 0 at 1, and then I load 1, B, and I add, and I return. It's direct, right? Any questions here? Yeah. No. B. Yes. Yeah. Add will pop. Yeah, you can say pop. Yeah. I add instruction will push the result onto the stack. And yeah, but then how many local variables are there? It's written there. 3. And just above the function is written, how many local variables are there? 2, right? It's only A and B. The parameters are considered as locals. But who is putting that there in the stack? The guy who is calling. Say, if it's the main, it is So it's a by push 100, by side push 100, so it's 200, so it pushes that. And then it calls the method. So that's all fine. Now, I'm not sure whether you see there is a difference. Can you see local stress 3 there? Why is it 3? Static and? It's not static. Good point. So, correct. So it is not a static function. So this pointer is I should not say pointer, it's Java, but this reference. When I say I should not say pointer in Java, what is the full form of NP? And Java does not have a specific set. So everything other than a primitive type is actually a pointer in Java, although we don't use it. It's called reference type. So it's actually a pointer to a reference. But as a programmer, we don't have to be bothered about it. But that was a side note. And yeah, that was an earlier code. After return, there cannot be a statement. Compiler would say that no. It will say unreachable code. We'll come to that. Oh yeah, so that is one more thing. I missed the slide. So you know this code, right? The first code which we write. But if you look at the bytecode, you can see that there is a constructor that is being put. So this is again the work of the compiler, the code generation. We are putting a default constructor out there. All of us know what a default constructor is, right? If you don't provide a constructor, the compiler automatically put. So that's other thing which the compiler does. And I'm sure you guys are tired with the compiler, but let's go deeper, one more level deeper. Simple looking code. How do you think the bytecode will also be? Fantastic. So this simple one-line code generates this whole stuff that's under the hood. So this is the constant class, and if you cannot read, that's fine. This is not sure that you can read. So it generates the constructor. It generates a final int I field. It would generate the getter. It is not going to generate a setter because it's a final field. So you have to initialize it when you are creating that record. Then it will also have 3 functions which are like derived from the object, which is like toString, hash code, and equals. Yeah. So that's about the record. Now that's only a beginning. Now I'm not going into the record patterns. That's another beast together. But let's come to a little another part of the compiler, which is like code generation. How many variables are there? How many locals are there, including the parameters? Five. It's listed there. And you look at the method description. How many locals are there? 4. Why is that? I variable in the second loop? Right. So I and j simultaneously is not there. So that analysis the compiler does. And what does it do? It would say that I require only 4 variables at the maximum at a time. What is the whole point of it? And what is the whole point of this optimization? Memory. So where does it come? When one function calls another function, there is a stack frame, there is a call stack frame, and it reduces the memory, right? So this sort of analysis is done by the compiler and gives a result like it generates something called a local variable table, LVT, where it says from which this is the list of instructions. You don't have to understand or go through any of these things. But only thing you need to look at is from PC 4 to 20, that is 4, that is go to 14, and to 20, not inclusive of 20, that's what it means. The I is allowed. From 22 to 38, J is allowed. Both share the index 3. Index 3 is like it's an array of locals and it shares the same thing. As he said, as I said, it's like kind of a reuse. And, anyone use this feature called auto closables? Auto closables is like if you have something called a file or something like that, you want to close it, and many times you forget it. So it's not a new feature. It's been a few years, where you you declare it in the try statement, and the compiler will automatically close it for you. I mean, so when it say automatically close, it will add code to close it. So it will say y.close at the end of the try block. It's like putting a finally and putting a y.close, so that you don't end up with having so many open descriptors of files. That is stat maps, which is like a verification stuff. I'll not go into the real details of it, because it's like when you run program, the JVM runs when Samir runs the program. So it will tell you, your program is not correct. Your program has problems. Your program is not have. I expect 2 integers at instruction at PC 100, and you have one integer, 1 float. So this kind of verification mechanism is being done to make sure that the program is not malefic. The program is generated by someone who is really generating the program, not somebody who's trying to do stuff. I don't know how they really misuse it, but this verification information is generated by the compiler, which tells you what is the local stack, what is the operand, what is the type of the operands in the stack, in the operand stack, what are the local variables available to you, and at every control flow, it puts this information, because if it's a sequence of instructions, it is easily derivable, but otherwise, at the control flow, there is a goto, etc., it puts that information. And that's another thing that the compiler generates. And it does a lot more. It's not just the instructions, it does a lot more. It does implicitly, now you don't even have require a class. There is something called implicitly declared classes, and exception tables, pattern switches, etc. Now, just this is, we've come to how the compiler, finally the old slide, and how the compiler internally looks like. It has a parser, abstract syntax tree, types, flow, etc. And many of these upward stream, they hook onto these pipelines. But we also said that compiler would flag errors. I know we have gone through some of the scenarios. So since I have 10 more minutes to torture you, I'll continue with this. So this is a very simple error, right? This particular modifier is not allowed. You cannot have a protected this one. But I think this we've already seen. Any errors? Any warnings here? Which code is not reachable? Yeah, it is not reachable. Correct. Anything? So it's a dead code. Yeah, it's not reachable. Fine. What is the anything else? X and X? Well, that is perfectly fine, because we are not assigned anything. Huh? Initialize the final variable, but we can use it at a later point in time. You don't have to initialize it. You can initialize it only once. You're not using this variable, right? It's another. You're just only assigning value to it. You're not using to it. So these are the subtle flow analysis which probably escapes. And now, I know some of you have not used this pattern switches, but there is an error here. Can you figure out what the error is? 7th line is, what is the error? Correct. Because you are doing something which is like a parent thing, and then, yeah. So you have to have more specific stuff. So if you're switching on an integer, the first one catches all the integers, so it will not go down. But this is fine, right? Can you see a loop here? Is there some loop here? There's no loop, right? Direct code. Now the compiler actually internally puts a loop here. It says, can you see this go to 9? It's a loop back. It's a loop back to this thing. So the trick here is, how do we implement this? First says it's a switch O, it's an integer. If it's an integer, when I greater than 10, you return 10, otherwise you return I. So it checks, before switch comes, it checks whether I'm an instance of integer. Perfect, fine. Then it says, okay, it's an instance of integer, then you go to the first case. Then once you reach the first case, you figure out that, okay, it is less than 10. So what do? You have to go back. But then when you go back, it will immediately say it's an integer and it will come to the first one. So what it does is, what it does is, it internally has an integer associated with it, a restart index associated with it. It restarts the stuff and increments one by one, and then say that if it is 1, you switch on to case 1. If it is 2, you switch on to case 2. So there is internally there is a loop that is coming. That comes to your point. Somebody asked whether there are performance issues. No, this is one small performance thing you can say. But then when I ask you, is it possible to do this in your earlier Java? It's not possible. You'd have to use a if statement. What is an if statement? Again, there is an if, check for this. Then again, there is an else. There is internal. There is no loop as such, but there is a control flow. There is a go-to associated with that. Intently, that's how it translates to. Here also is a go-to translates to. Sorry. Possible. You can use it, yeah. Subject to some conditions, but yes, you can use.
They say the fact that they will build in more smart testing analysis.
Stack size, this is stored. The stack size, everything is stored in the bytecode, in the .class file.
Yeah, so that they will bring down when they generate that. Because they bring up so much performance.
Okay, that you should ask the runtime guy. So, yeah. Yes, yeah. Second case is reachable because it's an integer. Your first one, suppose you're passing integer as a -1, then the first case comes and it says, okay, it's greater than 10, so this is not the right switch case. So we go back and go to the second switch case because it's an integer. After all, you're passing an integer. -1 is an integer, boxed, of course.
Okay, so this means
break is a good question. The break is actually implicit. There is a break. Yeah. No, there is a break. It's a break. So, in fact, when we do the intermediate representation, we actually insert a break, a yield actually. So, yeah, in the AST. That's internal, so maybe Java C is doing it separately, differently, but in our compiler we do that. So what else can you see in this code? This is open source, and just wanted to I don't know whether it's this is just philosophical slide. Yeah, so that philosophical state was to tell you that although it is open source, there are businesses built on top of this, because this is under Eclipse public license, the code. So you can use it in your company. You don't have to share. It's not like other licenses where you have to share the source code, etc. And there are working groups if you want to be part of it. There are different ways you can get involved. I just wanted to tell you that I'm part of this working group where we figure out how it can, what's the direction it can go, and different companies which are part of it. And if anyone is interested in contributing to the compilers or the tools or any part of Eclipse, please reach out to Eclipse community, to me, to any other person out there. Help you out. And also thanks to Gits, this is a place where I spend one of my beautiful years when I was a student here. So thanks to Gits for getting me here, and thanks for the wonderful audience, very interactive. Really enjoyed it. I'm not sure about you, but I really enjoyed it. Thank you.